Hi friends, yesterday's class we have discussed about types of fractions, right? So in that one fraction is being left, that is nothing but complex fractions. So what is this complex fractions? Complex fraction is nothing but it is a fraction in which one or both fractions are fractions. I got you got confused, right? So I will explain with one example. Okay, let's assume that we have initial fraction as 1 by 2. Okay, 1 by 2, this is the fraction, but 1 by 2 by 3, 1 by 2 by 3, this is nothing but this is the whole numerator. Now this is the denominator. Okay, this is totally numerator, this is the denominator, this is the main fraction. Okay, this is the main fraction bar. If the fraction is in this format, then it is called complex fraction. That means in numerator itself we have a fraction. This is our denominator, this is numerator. In numerator we have again fraction, so this is called complex fraction. So we can convert this complex fraction into normal fraction. So simply this 2 will come down. So then 1 by 2 into 3, so what it will become 1 by 6, right? So this is one type. So we can have another type, right? Suppose 2 by 1 by 3. Now here in the denominator we got a fraction. This numerator is 2. Okay, in denominator we got fraction. This is the main fraction bar. So if this is the case, what is the answer? So simply this 3 will go up. Okay, 2 into 3, that is nothing but 6. Okay, what if sometimes we have suppose 1 by 2 by 3 by 4? So now in numerator fraction only, in denominator also we have a fraction. Then in this case what we have to do, simply you take this 4 here and you take this 2 here, that's it. So simply what happens, 1 into 4 divided by 2 into 3, that is nothing but 4 by 6. So these are the different types of complex fractions you have. The fraction can be in numerator, the fraction can be in denominator, or both fractions, numerator and denominator can also be a fractions. These are called complex fractions. Okay, so this is how the complex fraction works, and how to solve, how to make the complex fraction into normal fraction also I have told here. Clear? Okay, now we are going to see about comparison of fractions. Comparison of fractions. If we want to compare fractions, if there are two fractions, suppose we have 1 by 2 comma 3 by 4, these are the two fractions. I want to see whether these two fractions are equal or not. Okay, are equal or not. What you have to do, simply 1 by 2 equal to 3 by 4. By seeing itself you can understand that these both are not equal, but you have to simplify this, cross multiply. Okay, just you do cross multiplication. What happens, 1 into 4 is nothing but 4 is equal to 2 into 3 is nothing but 6. Whether 4 equal to 6? No. So these two fractions are not equal. Clear? So again, if you take similar examples, again I am taking 1 by 2 comma 3 by 4 only. I want to check which is greater, whether 1 by 2 is greater or 3 by 4 is greater. I want to check that condition. Here also simply you should do cross multiplication only again. Okay, we got 4 is equals to, suppose 4, and here if you do, that is coming as 6. Whether which is greater, 4 is greater or 6 is greater? We already know 6 is greater than 4, right? If 6 is greater than 4, what is right side? 6. Here what is right side? 3 by 4. Simply 1 by 2 is less than 3 by 4. So this is how we come to a conclusion. Clear? This is how we come to a conclusion. Just to cross multiply and you check which is greater, automatically that fraction will be greater than the other fraction. Okay, just cross multiplication you have to do. This comparison can be done, this cross multiplication method can be used when we have only two fractions to be compared. Okay, when you have only two fractions to be compared, then you can directly cross multiply and get the answer, and you can easily get which fraction is greater than which one. But what if you have three fractions, suppose 1 by 2, okay, 3 by 4, let us assume 1 by 6. What if you have three fractions, and if you want to compare these three fractions, now which one is greater and which one is smaller? If you want to compare, what you have to do in this case? First you have to take LCM of denominator. Okay, LCM of denominators. What is the LCM of denominators here? 2 comma 4 comma 6. Okay, what is the LCM? 2 ones are 2 twos are 2 threes are, right? So what is going to be 2 into 2 4, 4 into 3 12, right? So you are getting 12 as the LCM. 12 as the LCM. Now you have to take 12 in each term. You have to convert these fractions in such a way that you should get 12. Now suppose 1 by 2 into 12. Okay, what is going to be at 6, right? But here for 1 by 2, what you have to multiply in order to get 6, in order to get 12? 6, right? So 6 6 for the first term. In the similar manner, for 3 by 4, what you have to multiply in order to get 12 in the denominator? 3, right? So here also 3. Again here for 6 you have to multiply by 2, so that you will get 12 12 12 in the denominator. So what is this? 1 into 6 is nothing but 6 divided by 12. This is 3 3s are 9 divided by 12. 1 2s are 2 divided by 12. So now the denominators are equal. Okay, denominators are equal. You can compare numerators. 6 9 2. 6 9 2. Which is greater? 9, right? So that's why this fraction is greater. 9 by 12 is greater than, again, 6 by 12 is greater than 2 by 12. This is how we come to a conclusion. That means we compare fractions when we have three fractions or 4 fractions or 5 fractions, whatever may be the fraction number. Okay, greater than 2 fractions. If 2 fractions are there, then we will just cross multiply and we will get the integer. We will check which is integer is greater, and we will simply mark our sign against that particular rational, that particular fraction. Okay, when 2 fractions are there, you should follow this method. Other than 2 fractions, suppose if you have 3 or 4 or 5 fractions, if you want to compare them, then you have to do first LCM of denominators. Make denominators equal. You should make all the denominators equal. Here they are not equal, so if they are not equal, we are unable to compare. So first of all, we need to make these denominators equal. So that's why I have made these denominators equal by taking LCM. We got 12 as LCM. So in every fraction, in order to get 12, I have multiplied with that corresponding integers. So I got 12. In numerators, we will get that particular values after multiplying. Then we can compare those numerators. So whichever numerator is greater, then that particular fraction is greater. So now here 9 by 12 is greater. 9 by 12 in the sense 3 by 4, right? So that's why 3 by 4 is greater than, what is 6 by 12? 6 by 12 is nothing but 1 by 2. So 3 by 4 is greater than 1 by 2 is greater than 1 by 6. So this is the final condition. Clear? This is how you have to compare the workings of fractions. Okay, if there are 2 fractions, simply cross multiply and get the answer. If there are more than 2 fractions, you have to do LCM of denominators, make denominators equal, and compare the numerators and write in that particular format, whether they are asking in ascending or descending. Okay, I hope you got it. Okay, in this way you have to compare all the fractions. Thank you.